The evening of September 3rd, 1939, settled over the North Atlantic with an eerie calm sea. The SS Athenia, a British passenger liner, cut through the gentle swells. Her decks, crowded with over 1,400 souls, fleeing the war that had erupted in Europe just hours before. Families huddled together, mothers clutching children, businessmen nervously smoking cigars, students whispering in hushed tones. None of them saw the shadow lurking beneath the waves. About 200 miles northwest of Ireland, Oberleutnant Fritz Julius Lamp peered through the periscope of U-30, his submarine's crew holding their breath. The setting sun reflected off the unidentified ship's hull. In the fading light, something about the vessel's silhouette seems off to Lamp. Was it an armored merchant cruiser, a troop ship? The angle made it hard to tell. With Germany now at war with Britain, he had to make a split-second decision. At 7:39 p.m., the order was given. A single torpedo slipped from its tube and raced toward the unsuspecting liner. The explosion tore through the Athenia's hull. The concussion, ripping apart the engine room and instantly killing several crew members below decks. Lights flickered and then died as seawater rushed into the gaping wound. Within minutes, the ship began listing to port. Panic erupted on the crowded decks. Lifeboats were lowered in frantic haste, some crashing into the sea as inexperienced passengers struggled with the mechanisms. Women screamed as they were separated from their children in the chaos. The ship's radio operator desperately tapped out SOS signals as the cold Atlantic water rose steadily through the vessel. The truth would eventually surface, but not before the tragedy had claimed 112 lives, including 28 Americans. The sinking sent a shockwave through diplomatic circles and newspaper headlines around the world. For Winston Churchill, it was a propaganda gift, proof of German cruelty. For Franklin D. Roosevelt, it was a grim reminder of how quickly neutral lives could be lost in this new war. After the torpedo's deadly strike, U-30 slipped silently beneath the waves, leaving behind the chaos and screams of the sinking Athenia. Lamp ordered the submarine to dive deep and set course eastward, running quietly on electrical motors to avoid detection by any British warships that might respond to the distress calls. The crew moved with practiced efficiency, though some stole uneasy glances at each other. This wasn't a melee target they'd expected. As night fell, U-30 began the long journey back to Wilhelmshaven, maintaining strict radio silence. For days, they crept through the North Sea's treacherous waters, navigating minefields and evading patrols until finally the familiar coastline came into view. As they approached the heavily fortified submarine pens, signal lamps flashed recognition codes between the conning tower and shore batteries. The massive concrete bunker loomed ahead, its young entrance barely visible behind anti-torpedo nets and floating booms. Tugboats emerged to guide them in as dockhands stood ready to secure the lines. The construction of massive submarine pens during World War II emerged from a critical strategic imperative by Admiral Karl Dönitz, commander of Germany's U-boat forces and later the head of the entire Kriegsmarine. Dönitz, a veteran U-boat commander from World War I, recognized early in the conflict that his submarine's fleet's greatest weakness lay not at sea, but in their home ports, where they were exposed to increasingly efficient Allied air attacks. His relentless advocacy for protected submarine bases stemmed from both practical experience and grim necessity, as the traditional naval infrastructure proved to be inadequate against the growing might of Allied air power, particularly the British Royal Air Force's Bomber Command. The concept of fortified submarine shelters wasn't entirely novel when the war broke out, but it was Dönitz who pushed for the implementation. on an unprecedented scale. Having witnessed the effectiveness of British bombing against German naval facilities during World War I and observing the RAF raids on German ports between 1939 and 1940, Dönitz became convinced that without proper protection his U-boat arm would be crippled before it could achieve decisive results. His arguments gained particular urgency following the RAF's successful attacks on the U-boat base at Lorient in 1940, which demonstrated how unprotected submarines were when undergoing essential maintenance and resupply in open docks. Dönitz found a powerful ally in Albert Speer, Hitler's architect and later Minister of Armaments and War Production, who recognized the strategic importance of protecting Germany's submarine fleet. Speer's organizational genius and control over production resources proved crucial in turning Dönitz's vision into reality. The actual construction was overseen by Organisation Todt, the Nazi civil and military engineering group, under the leadership of Fritz Todt until his death in 1942, and subsequently by Speer himself. The collaboration between these men created one of the most formidable defensive systems of the war, with construction priorities often overriding other military projects due to Dönitz's direct access to Hitler and his position as one of the few military leaders who maintained the Führer's confidence throughout the war. The engineering challenges involved in building these pens were staggering. Each facility required hundreds of thousands of cubic meters of concrete, thousands of tons of steel reinforcement, and an army of workers laboring around the clock under often brutal conditions. The French ports selected for these bases, particularly Lorient, Saint-Nazaire, La Rochelle, and Brest, were chosen for their strategic locations facing the Atlantic, but converting them into a fortress required a complete reimagination of traditional port infrastructure. German engineers developed new concrete formulations and construction techniques to create structures that could withstand direct hits from the largest bombs available to the Allies at that time. The roofs of these pens were designed with multiple layers, often including a softer concrete layer to absorb blast energy beneath the harder outer shell, a concept that anticipated modern composite armor principles. What made these pens remarkable was their comprehensive integration of all necessary support functions within the protective concrete shells. Unlike traditional naval bases, where different functions were spread across various vulnerable buildings, the German submarine pens housed everything from torpedo storage and workshops to crew quarters and command centers within the same fortified structure. This all-in-one design meant that even during sustained bombing campaigns, U-boats could be repaired, rearmed, and resupplied without exposing men or materials to aerial attack. The pens included sophisticated ventilation systems to remove diesel fumes, specialized cranes for handling heavy torpedoes, and even protected electrical substations to ensure continuous power supply, all designed to maintain operational capability under the most severe bombardment conditions. The strategic impact of these pens was profound. By providing a secure base of operations, they allowed Dönitz to keep his submarines longer at sea and rotate them more efficiently between patrols. The psychological effect on U-boat crews was equally important. Knowing they had an almost indestructible haven to return boosted morale among the men who faced some of the most dangerous duty in the war. The pens also forced the Allies to divert resources into trying to neutralize them, with entire bombing campaigns devoted to pen destruction that might otherwise have targeted other strategical objects. The Allies eventually developed special tactics and weapons specifically for attacking the pens, including the famous Tallboy and Grand Slam earthquake bombs. But even these only achieved limited success against the most heavily fortified structures. The submarine pens at La Rochelle formed one of the greatest naval fortifications of the Atlantic Wall, with an intricate system of outer defense and maritime infrastructure designed to protect the U-boat fleet while accommodating the complex tidal conditions of the French Atlantic coast. The entire complex was built around an existing wet dock at La Pallice port, which the Germans massively expanded and fortified to create an indestructible submarine base. The outer perimeter began with a series of anti-submarine nets and torpedo booms stretching across the harbor entrance, made of thick steel cables suspended between floating devices and reinforced with minefields to deter British commando raids or midget submarine attacks. Approaching from the sea, any vessel first had to navigate through a carefully designed lock system that solved the problem of La Rochelle's significant tides, which varied by as much as 6 meters between high and low water. The Germans constructed a massive tidal lock measuring over 150 meters long and 25 meters wide, with steel gates thick enough to withstand direct hits from aerial bombs. This lock chamber allowed submarines to enter or exit at any tide state, maintaining consistent water levels within the protected basin area. Flanking the lock were 2 fortified control towers, equipped with range-finding equipment, searchlights, and anti-aircraft positions. Their concrete walls angled to deflect bomb blasts. Beyond the lock stretched the enormous artificial basin, covering approximately 28 hectares of water surface, surrounded by quays of reinforced concrete with embedded railway tracks for moving heavy equipment and torpedoes. A series of smaller finger piers extended into the basin like the teeth of a comb, allowing multiple submarines to moor simultaneously while undergoing maintenance. The water area itself was over 8 meters deep to accommodate the draft of Type 9 U-boats even at low tide. The perimeter security extended inland through multiple concentric defensive rings. First came a 3-meter-high wall, topped with barbed wire and punctuated with machine gun nests in concrete pillboxes. Beyond this stood a minefield belt, then an anti-tank ditch, backed by reinforced concrete positions for 75mm guns. The entire landboard side was further protected by flak positions with 88mm guns mounted on massive concrete pedestals, their firing arcs calculated to create overlapping fields of fire against both aircraft and ground attacks. The basin's water circulation was carefully engineered with a system of gates and channels that allowed continuous water exchange to prevent stagnation, while underwater microphones detected any attempted sabotage by divers. The entire perimeter was illuminated at night by searchlights mounted on retractable towers that could be lowered into concrete shelters during air raids. This combination of maritime engineering and military fortification created what German propaganda called the unsinkable aircraft carrier on the Atlantic coast, a base that survived countless Allied bombing attempts and remained operational until Germany surrendered in 1945. The La Rochelle submarine pen complex was an architectural and engineering marvel of the Third Reich's naval infrastructure, featuring 11 individual docking bays that were each designed as self-contained submarine maintenance and repair facilities. The multi-floor design of each dock was a carefully calculated response to to the complex operational requirements of U-boat warfare, the physical constraints of the massive concrete structure, and the need to maximize efficiency with the limited protected space of the fortified enclosure. Each of these 11 docks followed the same fundamental tree-level vertical organization, but with subtle variations in equipment and layout, depending on their specific position within the complex and their designated functions. At the very foundation of each dock was the submerged operational level, a carefully engineered underwater workspace that extended from the basin floor up to the waterline. This zone maintained a constant depth of 8 meters to accommodate the draft of Type 7 and Type 9 U-boats, with the concrete walls featuring specially designed fendering systems made of timber spaced 50 centimeters apart to protect both the submarine hull and the dock structure itself. The basin floor was not flat but slightly sloped toward the central drainage canals that fed into powerful pumping stations capable of completely draining the dock in under 4 hours when necessary. This underwater level was illuminated by waterproof lamps installed behind thick glass portholes set into the dock walls at 2-meter intervals, creating adequate visibility for divers performing hull repairs or inspections. Rising above the waterline was the primary working deck, an expansive 2.4-meter thick reinforced concrete platform that formed the heart of each dock's operations. This level extended 15 meters back from the dock edges on all sides, creating a vast workspace that was precisely leveled within 5 mm tolerance across the entire surface. The deck was divided into functional zones by color-code painted lines that directed the flow of men and materials: yellow for torpedo handling areas, red for fuel transfer zones, blue for electrical work, and white for general maintenance. The surface was textured with a pattern that provided secure walking even if covered by oil or seawater. At regular intervals, flush-mounted steel rings served as tie-down points for heavy equipment, while large access hatches provided entry to the utility tunnels running beneath. Along the walls, a continuous workbench ran at 90 centimeters height, fitted with mounts, electrical outlets, and compressed air connections at 2-meter spacing. This main working level also contained several permanent installations in each dock, including a 5-ton jib crane near the bow position, a torpedo loading gantry, and a diesel-fueled transfer station at the stern area. The intermediate level, located 6.5 meters above the main working deck, housed the dock's mechanical infrastructure in a series of reinforced concrete alcoves set into the perimeter walls. To port were the electrical distribution rooms with their massive converters and switchgear. To starboard were the compressed air stations with their banks of high-pressure storage flasks. Aft housed the ventilation and control centers with their complex systems of dampers and filters, and forward contained the emergency power generators and fire suppression controls. The upper operational level at 13 meters elevation was more variable in its layout between docks, reflecting their specialized functions. In the 6 central docks, this top floor formed a complete mezzanine covering about 70% of the dock area, housing the dockmaster's control room with its panoramic windows, the radio monitoring station, and the precise instrument workshops. The remaining 3 docks to the north had larger open areas at this level to accommodate the overhead crane systems needed for conning tower repairs. This sophisticated multi-level design allowed each of the 11 docks to function as an independent repair facility, capable of handling all aspects of submarine maintenance, except the most extensive overhauls. The vertical separation of the activities improved both safety and efficiency, Potentially explosive battery work happened on the submerged level, away from the spark-producing metalwork on the main deck. Precision optical work occurred on the stable upper levels, away from the vibrations of the heavy machinery below. The design also provided redundancy. If one level was damaged, work could continue on others. And security, as access between levels could be easily controlled, with over 38,000 square meters of functional workspace distributed across the multiple levels in the complex. La Rochelle pens could service up to 22 U-boats simultaneously, while protecting them from Allied bombs. A testament to the ingenuity of German naval engineering at the height of World War II. The process of reloading torpedoes into submarines housed within the massive U-boat pens of La Rochelle was an intricate and labor-intensive operation, requiring meticulous coordination among specialized personnel, careful handling of heavy and volatile ordnance, and the use of purpose-built machinery designed to function with the confidence and heavily fortified environment of the bunker. The reloading procedure itself was a carefully choreographed sequence influenced by the submarine's design, the layout of the pen, and the need to maintain operational secrecy and safety. Before a torpedo could be loaded, it first had to be transported from one of the heavily guarded storage areas within the pen complex. These storage rooms were often located in chambers or in the rear section of the bunker, shielded by thick concrete walls to prevent catastrophic explosions in case of an accidental detonation or an enemy bomb strike. The torpedoes themselves were delicate, yet extremely dangerous weapons, weighing between 1.5 and 2 tons each, depending on the type. They were filled with explosives, compressed air, and in case of electric torpedoes, volatile batteries that required cautious handling. Given the weight and sensitivity of the torpedoes, any sudden jolt or mishandling could result in damage of the weapon, or worse, an accidental explosion, so movement was slow and deliberate. Once the torpedo trolley reached the designated U-boat, the next phase of the operation began, lifting and aligning the torpedo for insertion. This was accomplished using heavy-duty overhead cranes, which ran along tracks mounted on the reinforced concrete ceiling of the pen. The cranes were capable of lifting multiple tons and were operated by experienced technicians who carefully maneuvered the torpedo into position. The submarine's crew, working in tandem with the dockyard personnel, would prepare the torpedo loading hatch, typically located on the forward deck, for bow tubes, or alongside the hull for stern tubes. Some U-boats, such as the Type 7 and 9, had external torpedo storage compartments that required additional steps to access. The cranes were capable of lifting multiple tons and were operated by experienced technicians who carefully maneuvered the torpedo into position. As it was lifted, teams on the submarine's deck guided it into alignment with the open torpedo tube or loading hatch. Inside the submarine, the torpedo room crew would receive the weapon, sliding it into place within the tube or storage rack. This step required extreme precision, as even a slight misalignment could jam the torpedo, rendering it unusable until manually freed. A time-consuming and dangerous task. Once inside, the torpedo was secured, connections for guidance systems were checked, and the tube was sealed. The typical attack submarine, carrying between 12 and 22 torpedoes, depending on its class and mission profile. Given the claustrophobic conditions inside the pen, dim lighting, limited ventilation, and the ever-present hum of machinery, the work was physically grueling. Additionally, the threat of Allied bombing, though mitigated by the pen's thick roof, meant that efficiency was paramount. Some PANs had even emergency protocols for rapid reloading in case of an imminent alert. After all torpedoes were loaded, final checks were conducted to ensure proper arming and functionality. The U-boat's crew would then prepare for departure, often within hours, as the La Rochelle base was a key hub for Atlantic operations. The PAN's ability to facilitate rapid rearming and repairs was a critical factor in Germany's U-boat campaign, allowing submarines to return to sea within minimal delay. Despite their formidable defenses, however, the PANs were not invincible. Allied raids, sabotage, and logistical disruptions eventually reduced their effectiveness as the war progressed.